Hello. The example on the left is in a separate video. The setup for both of these is pretty similar, and then the algebra for actually evaluating the limit or finding your final answer, that algebraic process becomes different. But over here on the right, they gave me g of x equals 1 over x, and then I see this weird g of x plus h business. And so one of the tricks that I showed you for dealing with that, mathematically, it doesn't really mean anything, but it might help your brain kind of make sense of it. If g of x equals 1 over x, then g of box equals 1 over box. I'm actually going to write that twice. Once for the first term up top, and then another time for the second term up top. One of those is hopefully clearly easier than the other two. But now that I've written it this way, so I've just replaced the x's with boxes, and then I'm ready to actually fill in those boxes. Well, here I want g of x plus h. So this box, and therefore that box, get filled in with an x plus h. Just kind of cleaning that up. So this first term that I've underlined in red is just 1 over a denominator of x plus h. Notice that that h ended up underneath, and that's one of the things the box trick can help you with. Now the second one, you really didn't have to do any work here. This says g of x, so I'm going to fill in these boxes with x's. That's what they were originally. G of x equals 1 over x. We did that with the box trick, but also they specifically told me that to start with. Okay. So the box trick works. You don't have to use it. It's not some brand new mathematical thing that I've invented. It's just a way that might help you think of it. It's helped students in the past, so maybe it'll help you. So what we have now, for that limit, I'm going to use the work that I've done, and I'm going to use my color coding. So I have a big fraction with h in the denominator, some subtraction up top, and I have g of x plus h. We figured out earlier that was 1 over a denominator of x plus h, minus g of x. We figured out earlier, but also the problem told us, g of x is 1 over x. And so now this looks like one of those fraction inside a fraction problems. I'm even going to put parentheses to kind of make it super clear which ones are the little fractions versus the big. And I'm also just going to recopy this all in black, a little bit more smushed together so we can start doing work with it. And in class on Tuesday, today, you saw some different methods for dealing with this fraction inside a fraction. The method that once you get used to it does really, really good things for you is the second one that I showed you. The common denominator trick works, and in this case it works about the same level of difficulty as the other, but the method I'm going to do here is the second one I showed you, and it works in tons of situations we're going to encounter. So let's try to maybe get used to that now. What that method is I look at my little fractions. I see a little fraction with an x plus h denominator. So I'm going to multiply my big fraction by x plus h on top and bottom. Likewise, I see a little fraction with a denominator of x. So I'm going to multiply my big fraction by x over x. If you wanted to put a fraction bar there, you could, but whatever we do to the top, we also have to do to the bottom. And so at this point, the denominator is basically taken care of. The denominator has an h that was already there. It also has the x plus h that we multiplied by. It also has an x that we multiplied by. The numerator is where it's going to take some work. With practice, you're going to be able to fill this numerator out without doing any scratch work. But I'm going to show some scratch work off to the side to explain what's happening here. Because my job is to take x plus h times x and distribute it here and here. So what I'm going to do off to the side as some scratch work is each of those distribution steps. So let's do the first distribution step. I have 1 over x plus h, and it's getting multiplied by x plus h times x. So this denominator and that x plus h, they cancel, and that was the whole purpose of us putting that blue x plus h there. So this distribution step just gives me an h left over. Oh my gosh, no. Let me do that again. In orange, my apologies. Let me start that all over. My goodness. It is early. I'm going to try that one more time. Sorry about that. That was just bad copying. We have a 1 over x plus h. And then if I copy it correctly, we have a blue x plus h. And we have an orange x. I had written that wrong a second ago. But the canceling still happens. And I'm left with what I should have said before. I'm left with an x. And then my second distribution step. I'll deal with that negative a little bit later. I'll just kind of throw that down there. Let me try to write it correctly this time. So I have a 1 over x, and it's getting multiplied by a blue x plus h, and an orange x this time. And so there, this 1 over x and that x cancel, and we're left with the x plus h. And because of this subtraction, make sure you put some parentheses around that to remember to subtract all of it. But that process, the scratch work off to the side, honestly, I usually do this in my head, and I think I would have done it right in my head the first time. But that scratch work process off to the side is just a reminder that I'm just distributing. And so this was my first step distributing, that first arrow. This was my second step distributing, that second arrow. And then they both show up in the numerator. So now I don't have little fractions inside big fractions. I just have a rational expression. So at this point, this has become quite a bit simpler. My denominator, I'm going to leave that in factored form. Because if I can keep all those parentheses in there, then I'm going to be able to hopefully cancel some things in just a minute. The numerator, I need to deal with that subtraction and simplify that. So I have x minus x, which is nothing. Those cancel. And then minus h. So my numerator is negative h. X minus the quantity x plus h. And as I've mentioned, both in the other video and during class today, if you've set this up correctly and you haven't made the silly mistake I almost made a moment ago, those h's should cancel. So I'm left with limit as h approaches 0. My numerator has a negative still. My denominator has this. And once we've canceled, we go back to direct substitution. The trouble is, not really trouble, but the unusual thing here is that we have two variables. And so the question is, well, which one of those is supposed to get replaced? This tells me. When we do direct substitution, we say, okay, instead of whatever approaching a number, let's just let it equal that number. So this right here tells me that it's the h that gets replaced and the x's get left alone. So my numerator is going toward -1. My denominator, the x is still there, that's fine. The h has become a 0. The x over there is still an x. And at this point, you've done all the calculus, you're just left with some basic boring algebra, so you can stop there. If you wanted to simplify, that's -1 over x times x, which, go up, there we go, which is this. But remember, once you've done the calculus part, I don't care about your arithmetic or your algebra skills. I trust that you know that x times x is x squared. You don't have to prove that to me. You do have to prove to me that you know how direct substitution works. Let me zoom out so you can see all of that at once, including that scratch work. And remember that other problem is in a separate video, just so you wouldn't have to search through if you only needed help with the second problem. So I'm going to stop recording, which means you're going to see my face for just a moment. Oh, and the announcements are coming on. See you shortly.